Hello everyone, this video is to show you the process of setting up a i1000 test program to get it ready for production use. So to start off, I have some files that we will use for the videos. So obviously we will need the ATD file. The ATD file is basically the i1000 test program that will house all the test parameters and the test details itself. Together with this file, you have some other files like the BOM, the log file, the pins, and the nails files. The BOM is the formatted BOM that we use to generate the test program using the BOM to ATD software that is provided by the i1000 itself. Then using the BOM to ATD converter, you would have a log file which actually describes to you, what are the components that is successfully being converted and what is not. And then of course you need to have the nails and the pins files, which is the CAD output from either FabMaster or CAMCAD software itself. So notice that all the file names of these files are the same. It's only that the extension is different, and it is very important to have all these names being correctly all these files being correctly named to follow the ATD file name. Is because when we load the ATD into the i1000 software, the i1000 software will actually attempt to bring in all these files as well. And these files, for example, the pins file and the nails files, these are actually being used for the coverage analysis in the i1000 software itself. Okay, so let's start off by launching the i1000 program. Double click and username to be i1000, default password i1000. And there you go, the i1000 software is loaded, and you can now go ahead and open up the ATD file either from the file menu or by clicking the icon itself. So let's open the file menu, path it to the demo files directory, select the ATD files and select open. And you notice that the software will actually do some conversion to read in the pins and the nails files during the launch itself. So now you have the software already loaded, the test program already loaded onto the i1000 systems. The next thing that you need to do is to perform some simple setups for the software. Right, so go to the setup menu, click, select the system setup and system parameters, or alternatively you can just press F8 to go into this to launch up the system parameters window. So let's click on this and you have the system parameter window being launched. So let's go through a little bit on what are these parameters all about and how would they help you in your production environment. So first of all, on the reporting section, on the report section, there are some parameters that you can choose. For example, the first one is maximum fail report. This basically helps you to make a control of what is the maximum number of failure report that you want to allow the system to print out when a failure occurs. So this is regardless of whether is it a single board or is it a panelized board. For example, even you have 4 boards in your panel and you have about a total of a maximum of 10 failures, right? If you set the maximum of 10 over here, the maximum number of failure report that it will be printed out will be 10, regardless of how many boards itself is failing. Okay. So I'm going to leave it at 0. 0 basically means that it will print out everything, right? Display all is you just put 0. Reporting common device for opens and shorts test. Okay, so this basically controls how many common device will be reported when there is an open or shorts failure. And of course, the Another one is to control the maximum number of component fail reporting. Okay. Then you move down to the hardware portion where you have the printer setup. So this part is pretty much straightforward. You have printer connected to LPT to your printer port, then just leave it as LPT1. If you have it connected to your COM1 instead, then leave it as COM1. Or you choose not to have any printer at all, just turn it off. Then you have the fixture type. The software, the same set of software is actually capable of basically the vacuum and the press down model at this point of time. Inline model right now is not available yet. So this will have to tie down with whichever system that you are using on the production floor itself. So I'm going to leave this with the press down system. And then now there are some other features or other parameters that you can set. So first of all is the repeat cycle. Repeat cycle is more of a demo purpose or maybe as a feature that you can use to loop your test, loop the whole test of the board for a number of times just to check that the test is stable and there is no false calls or false rejects occurring. So if you set this at 100 times, what happens is that the moment you click test, the test program will continue to loop for 100 times regardless of pass or fail. Even when there's failures, it will still continue to loop 100 times. Right? This is actually meant for you to do some looping tests. Well, all the failures will be recorded, so you do not need to worry that you need to capture the failures at all. So I'm going to leave this back to 0 for the production use. Right? Production yield limit is to allow you to set an alarm, or basically a limit of how low the first pass yield can be. If I set a 95%, if the first pass yield falls below 95%, the software will actually stop, and it require a technician to actually come in and reset the software again. So in this way, basically the technician or the test engineer itself can actually monitor the line and ensure that the line yield rate is operating at a nice level. Then you have the decimal places. This basically controls how many decimal places to be displayed for all measurement values and for all settings values that you have in the software itself. Right? For test limits, for measured values itself, how many decimal places to display. And the last one is failure graphics. Turning this on will have the software automatically load up the board graphics and show you where the failure of the component is, or rather where the failing component is in cases where there's a failure. Right? Just bear in mind that this will actually incur some time, because whenever there is a failure, the software will actually need to go and extract the information and actually display the board graphics itself. So it may not be that useful for actual production use. It may be more useful for your debug purposes only.